We got a quick lesson. We're going to go over matrices today, a few things that you need to know about matrices, how to set them up. So the singular is matrix, and a matrix is a set of numbers, variables, or other elements that are arranged in columns and rows. And its dimensions are given in rows by columns, or R by C. So for example, this here is a 3 by 2 matrix, 3 by 2. Or sometimes we write it in brackets like that, 3 by 2. We can see that it has 3 rows, 2 columns. So if you're ever given the dimensions like this, the first number is how many rows it has, and the second number is how many columns it has. Now, if we want to add two matrices together, or if we want to subtract the two matrices, all we have to do is add or subtract their corresponding elements. So that just means if I'm looking at the first position in the first matrix, I'm going to add that to the number that's in the first position of the second matrix. So let's look at these two matrices here. This matrix is 2 by 3. This matrix is also 2 by 3. Matrices need to have exactly the same dimensions in order to be able to add them or subtract them. So if I add this matrix to this matrix, I'm going to add 3 plus 7, 4 plus negative 2, and negative 8 plus 9. Over here. I can't move my cursor out of the way. There we go. Negative 8 plus 9. Then I'll add negative 8 plus negative 4, 1 plus negative 9, 0 plus 3. And then all we do is simplify this. So 3 plus 7 is 10, 4 plus negative 2 is 2, negative 8 plus 9 is 1, negative 12, negative 8, and 3. So that's all there is to add addition or subtraction. If this were subtraction right here, all we would do is do 3 minus 7 and continue that process along. Now, in addition to addition and subtraction, we can talk about matrix multiplication. And there's actually two types of multiplication. The first type of multiplication is scalar multiplication. And that is when you have a scalar, and a scalar in matrix algebra is equivalent to a constant in basic algebra. So scalar multiplication means multiplying a matrix by a real number, and the result is a matrix that is the same size as the original matrix. Now there's another type of matrix multiplication, which is where you actually multiply two matrices together. And knowing how to do that is not in the standards on the Ames test, so we're not going to go over that here, but you will go over it in your algebra classes. So if we have a scalar, like this number 2, and we want to multiply that by this matrix, all we do is multiply each element in the matrix by the scalar. Okay, so for example, if we want to multiply this 3 by 3 matrix by this scalar 6, all we do is multiply each of its parts by 6. So for example, we'd have 6 times 3, 6 times negative 8, 6 times 7, 6 times 8, etc., etc., etc. So what we see is a result that is still a 3 by 3 matrix. So we'd have 18, negative 48, 42, 48, 24, negative 12, negative 6, 6 times 5 is 30, 6 times 0 is 0. So this is our resultant matrix, and we can see that it maintains the same size. It's 3 by 3. Now the reason that matrices are so important is because it's such a useful way of organizing information. So let's go over an example of how you can use matrices to organize some information and use scalar multiplication to represent something that's going on. So here we have an example. Tyler, Emily, Libby, and Dan made $7 an hour for working at the car wash during summer vacation. The following matrix shows the number of hours each student worked in June, July, and August. So we really have two variables here. June, July, and August represents the variables months, and then Tyler, Emily, Libby, and Dan kind of represents the variable of people. And so we can represent those two different variables using our rows and columns. So here in my rows we have June, July, August. In my columns we have Tyler, Emily, Libby, and Dan. So for example, in June, Tyler worked 116 hours. In July, Emily worked 108 hours. In July, Dan worked 85 hours. And in August, Libby worked 93 hours. So this represents all the different hours they worked in all the different months. Now, if we want to represent how much money they made, we know they all earned $7 an hour. We have how many hours they worked, so we can multiply the matrix by a scalar. So here we see 7 times 116, 106, 98, 125, etc. So we're going to multiply each of these values by 7, this scalar, and so this matrix is going to represent how much money each of these people made. So this would be Tyler, this would be Emily, Libby, and Dan, and each one of these rows is going to be how much money they made in June, July, and August. So think about how you have two variables, how you can set up your matrices to represent them in rows and columns, and how you might use scalar multiplication to represent a situation that's going on in the problem. And you'll practice this in the problems this afternoon.